Welcome to my channel Insightful Babbage, and today we're gonna talk about what we call the epitaxy. What is all about epitaxy? We will learn about these all things, but first of all we're gonna talk about what we covered in the previous lecture. We covered the things about silicon, how a silicon is being grown from a crystal growth that you know from a Szyszorowski process, how we extracted silicon from the silica. That is the most important thing, the chemical reaction that we talked about. Then we talked about what kind of different defects into the silicon. We talked about the point defect, the area defect, and their dislocations and all those things. Then we talked about what we call the Szyszorowski process, through which we can grow the crystal throughout. We can grow the ingot, the substrate, and we got a cylindrical ingot, in the picture I showed you in the previous lecture. And afterwards, after slicing into wafers, we try to polish it and everything, and try to make it less contaminated. So that's our goal. So epitaxy is what about? Why are we creating all those things? The wafer that we created from Szyszorowski process is basically what we call a substrate, but we want a transistor. We want transistors. In If we want to have transistor, we have to have source and drain, and we have to create another layer on the substrate, that is the source and drain. So to create another layer is basically the meaning of epitaxial. So what is epitaxy? It is basically growing another layer on the substrate is known as an epitaxy. So epitaxy comes from the Greek word epi, means above, and taxis mean in an ordered manner. A layer growed above on an ordered manner on a substrate is basically defined as an epitaxy. So epitaxy has some orientation. You can go through the Miller indices. We can grow a layer on an orientation of 001 index, and there are two types of epitaxy. If the material that you are growing, the layer that you are growing on the substrate, is the same as that of the substrate, that is known as the homeoepitaxy. And if the substrate is different, if the layer is different than the substrate, then it is known as a heteroepitaxy. If we take an example of homoepitaxy, it is a silicon on a silicon substrate. And if we take a heteroepitaxy example, there will be a silicon on sapphire, there will be gallium nitride on sapphire, there will be aluminum gallium indium phosphide, there will be gallium arsenide or diamond or iridium, or we can take it is like a graphene or a hexagonal boron nitride. So that is the thing about heteroepitaxy. First we talked about homoepitaxy, then we talked about heteroepitaxy. Both are preferred, but we talk different types of process to create epitaxy. First of all, there are three different processes through which we can grow the epitaxy on substrate. What are the three ones? They are, first of all, the liquid phase epitaxy, and the second one is the vapor phase epitaxy, and the third one is the molecular beam epitaxy. In a liquid phase epitaxy, what happens is that we pass a liquid through the substrate, and what happens, the liquid get dried on the substrate, and a layer of the liquid has been formed on the substrate, and this is the way through which we can create a liquid layer which has been dried on the substrate, is known as the liquid phase epitaxy. Now we have the vapor phase epitaxy. Vapor phase epitaxy is basically in a chamber. We are passing some gas and all those things with the gas of the layer, and it reacts with the substrate. It gets deposited on the gas get deposited on the substrate, and through this we can clearly make a layer on the substrate through gas formation, through gas molecules, we can get the epitaxy. So let us talk about what is the vapor phase epitaxy. Epitaxial growth can be achieved from solid phase, liquid phase, vapor phase, and molecular beam deposition. For a Si epi layer, vapor phase epitaxy, which is a form of chemical vapor deposition, is the most common. Chemical vapor deposition of single crystalline silicon is usually performed in a quartz reactor into which a susceptor is placed. The susceptor provides physical support for the substrate wafer and provides a more uniform thermal environment. Deposition occurs at a high temperature at which several chemical reactions takes place when process gas flow into the chamber. So process gas is the main thing that flows into the chamber, and the reaction takes place on the substrate to form a different layer on the substrate. So what it is all about? It is introduction of the reactant species to the substrate. What are the reactants that are depositing on the substrate? Transfer of the reactant species to the substrate surface, absorption of the reactant species on the substrate surface. Then there is a surface diffusion, site accommodation, chemical reaction, and layer deposition. Deabsorption of residual reactants and byproducts, transfer of residual reactants and byproducts from the substrate surface, removal of residual reactants and byproducts from the substrate region. These are the 7 steps that it goes through. You know, this is a reaction chamber. We are passing H2, HCl as a reactant, and this goes through, and this is the substrate, and on that we can get a layer of it. So we go through an equation known as the Reynolds number, the type of fluid flow in a reactor, how it flows. The Reynolds number is given by dr v rho by mu, where dr denotes the diameter of the reaction tube, where v is the gas velocity, and rho represents the gas density, and mu stands for the gas viscosity. You know, the Reynolds number depends on so many parameters that we talked about: the diameter of the reaction tube, gas velocity, gas density. We want to get a uniform layer on the substrate, so there should be a constant gas velocity that forms the layer on the substrate. So we go through some reactions. If we talk about the flux of the reactant, of the flux of the gas, it is given by dg into ng minus ns by y. So ng is the gas stream reactant concentration, ns is the surface reactant concentration, where d is the gas phase diffusivity, that at what rate it is diffusing into the substrate, and y is the boundary layer thickness. And what we calculate basically from this equation, the reactant flux of molecules per unit area per unit time. This is what we're gonna calculate. So we studied about the vapor phase epitaxy. In the next lecture we will cover about the molecular beam epitaxy, but the most common one we used in substrate in a layer forming on substrate is the vapor phase epitaxy. Most of the process in the fabrication lab is on the vapor phase epitaxy. That is all about. We discussed the 3 types: liquid phase, vapor phase, and the molecular phase we will discuss in the next lecture. And this is all for the video, for just an introduction about what is called the epitaxy. If you like my video, try to subscribe my channel and click on the bell icon to get the notification of my upcoming videos. I'm making more videos on VLSI because let the people come into the market and know about what VLSI is all about. So thank you very much and have a nice day.